Algebra 1 students, welcome to your 5.6 notes, parallel and perpendicular lines. Today we're going to take what you have looked at with slope and linear equations, kind of take it to that next level where we look at applying that knowledge to do some things that are a little bit different. It shouldn't be a horribly complex lesson, but it's two distinct things that we have to take a look at. So let's get started here. Parallel lines. Lines are parallel, and you can see the notation here. It looks like railroad tracks. If they have the same slope, but a different y-intercept. And the reason the y-intercept has to be different is if it were the same, you would just have the same exact line. Now you can see the example I have here. Both lines have a slope of 3 over 2. So they're going up 3 and right 2 in both cases, and the y-intercepts are clearly different, so you can see the parallel lines. Now perpendicular lines happen when the slopes of the two lines have a product of -1. Another way of saying that is that the slopes are opposite reciprocals. You can see the example here. This red line is the same red line we have over here. It has a slope of 3/2. The blue line, though, now has a slope of -2/3. And you can see that with that information, with those two slopes, that the lines intersect to form a right angle right there. Or you could mark it here, or here, or here. It's right angles all around. All right, so let's take a look at some applications of this. Are the following graphs parallel, perpendicular, or neither? All right, so what we really need to focus on is finding slopes of these lines. In this case, the slope is 4/7, and that comes from this term right here, y equals mx plus b. And on the next one, our slope is also 4/7. Now, one thing we should be careful of is to be sure that we're not talking about identical lines. So I'm going to actually do some distribution here. Y plus 3 equals 4/7 x. 4/7 times 4 is 16/7. Now I know I would need to subtract 3, but I really don't need to worry about that because I've already answered the question. These lines are not the same, but they have the same slope, so they are most definitely parallel. Notice how parallel is spelled with 3 L's, 2, then 1. Interesting word. Spell it right. Give it a shot. On number 2, we're given the same question. We just have different equations to work with. So we could look at the first one, y equals -1/7 x. That tells me right there the slope is -1/7. And the second equation, it's y equals -7x plus 8. The slope has to be -7. Now it's really tempting to say that these are perpendicular lines because the slopes are reciprocals, -1/7 and -7. However, remember with perpendicular lines, their product is -1. That means one has to be positive, one has to be negative. We don't have that here. They're also not parallel because they're reciprocals. So we would say that in this situation, these are neither parallel nor perpendicular. All right, let's go on to the next one. Number 3, again, same instructions. This second line is the easier of the two. I'm going to go ahead and mark that. We know the slope there is 2. But the first equation requires just a little bit of extra work. So I'm going to go ahead and write this out. 4x plus 8y is equal to 11. Now what I'm going to do is subtract 4x from each side and write it this way, -4x plus 11. I'm really headed toward point slope, slope intercept, I'll get that right eventually, form. So y is equal to -1/2 x plus 11/8. Now, the reason I did all of this work is to get essentially one piece of information right there. I know the slope is -1/2. Slope of 2, slope of -1/2, those are perpendicular. Perpendicular lines, their slopes have a product of -1. The other way to think about it is that they are opposites, +2, negative, and reciprocals, 2, 1/2. Opposites and reciprocals. All right, let's take a look at our next slide here. A line passes through the point 4, -7 and is parallel to the given line. Find the equation in slope-intercept form. All right, let's start with this. Key information from this line is that the slope is equal to 2/3. Now, if you think back to what we said on the first slide, we said parallel lines have the same slope. So what we're talking about here is the slope of 2/3. That's the parallel slope as well. And it's also given that we go through the point 4, -7. Now I'm going to start with point slope form. So y plus 7 is equal to 2/3 times x minus 4. Let's do some distribution. 2/3 x minus 8/3. We could also subtract 7 from each side, which would give us our slope-intercept form of y is equal to 2/3 x, and remember 7 is the same as 21/3, so minus 29/3. Now if you prefer to write 29/3 is 9 2/3, that's totally fine. All right, let's take a look at the next one, number 5. A line passes through the point, -5, -1, and is perpendicular to this given line here. Find the equation in slope-intercept form. All right, we've seen this scenario before. When you start in standard form to find the slope, there are a couple ways to do it. You can actually memorize the pattern. I'm not going to spend a lot of time on that. So instead, we are going to solve for y. So y equals 2x. And it says -6. Honestly, we don't care about the -6. What we care about is that term right there, m equals 2. Now, if the slope of this line is 2, we've got to find the slope that's perpendicular, as it says here. So the perpendicular slope is the opposite. Well, this is positive, so it would have to be negative. And it's the reciprocal. The reciprocal of 2 is 1/2. So the slope is -1/2. Now let's plug in the point we know, -5, -1. So y plus 1 equals -1/2 times x plus 5. Now we're in point slope form. Unfortunately, the instructions do call for slope intercept, so we'll go ahead and do some distribution. We'll subtract 1. And then y is equal to -1/2 x minus 7/2. Piece of cake, isn't it? All right, it does take a little thought, a little work for sure. All right, last two. These are pretty quick. If you remember the little phrase, there's a little phrase that has to do with horizontal and vertical lines. Make sure you know it. If you don't know what I'm saying, what I'm talking about right now, you need to go look that up and make sure you learn that thing because it's massively important to you. Okay, this says to find the equation for the line that's parallel to y equals 8. Here's what you have to think about. This is a horizontal line. And it passes through the point 7, -5. We know that horizontal lines are always y equals equations. And I look right here and it says that y is -5. And folks, we're done with that problem. It's that simple. Okay, let's take a look at the next one. You got to think about this in a minute. Find the equation for the line, and there are a few things going on, that is perpendicular to the x-axis. Now remember, the x-axis is that one right there. Well, what's perpendicular to the x-axis? Well, that's the y-axis, or any other vertical line. We know that vertical lines are always in the form of x equals some number, and in this case that number has to be, you could even sketch it over here if you wanted to see it, 7. X equals 7. Hey folks, I hope these notes work for you. Make sure you understand the relationships between parallel lines and also perpendicular lines, how their slopes are the same and how they're different. You guys come to class ready to work and have a spectacular day.